Right now, integration by parts. Let's look at integration by part now. Now, integration by part helps us to integrate two dissimilar functions that are in terms of product, in form of product functions. Remember, we did product rule from this derivation for integration by part. We actually went from that product rule we did. Now, it's not that if we have integral u dv, we say we are going to take it as uv minus integral v du. This is the model coming from integration by parts. Now, what's the meaning of u dv? Those are the two functions you are going to have in the question. For example, now let's say e.g. let's say we have the guy s exponential x dx, something like this. This one something like this. This one is u dv. That's what I have in there. Integral u dv. Now the first one is not u. The first one is not u. We can also have integral s squared exponential x dx. We can also have integral x log x to base e dx. We can also have integral s cos x dx and so on. Now, this is integral u dv. Now, the problem with this arrangement is that the first one is not always u. The first one can be u, the first one can also be dv. Now, if the first one is u, if the one, I don't know, we have 1, 2, it's only two dissimilar functions. Now, look at all that thing. Out of these two, one of them will be u. We don't know the one of u. I'm not sure how to get the u out now. The way you have to do is to follow up. Then, if you can move out your u, the remaining one will now be dv. That will be the remaining one, not v. Now, how do you get your u? Now, to get u, look at what I'm going to do. To get u, because u is the only issue here. You can get your u, you're already good to go. Now, if you cannot select the u well, you will not get answer in the question. You will be solving till infinity, you will not see any answer. To get your u, or to obtain u, or to select u, other use is the first thing you check if you have log x to base e. That's the first thing you check. If this one is not there, then you move to, you check if I have s raised power n there. If this one is not there, then you check if I have exponential s there. So if this one is not there, if these are not present in that place, it shows that that is not an integration by parts. So you can use another way to unravel that mystery if you can. So, or you just choose the one you like, but these are the ones you should take as your u. This will be your u in the question. Your u. So this is the first one, the second one, the third one. If this one is not there, you take this one. If this one is not there, you take this. So if you check this question, we have s is power 1. S is there. It's s before exponential, so we are going to take s. Let's have to select it. Do this and this, s squared is there. S before this one, we're going to take this one. We do this and this one now. Log s is here. It's log s before this. We're going to take log s. This one now, it is x before any other function. And this one, any other function may be possible. The solid s that is here now, we're going to take this s. Not cos s. This is the other use if you want to select your u. So let's solve this first one now. Integral x exponential x dx. So we said the u will be, there's no log x there. Is there s is power something here? We have s is power 1. That's x is power 1. We're going to take now as u. Then, look at this formula. After we have select u dv, we have used v minus we have v du. What is not du? Now okay, du over dx. If you mention this s, what are you going to have 1. So if you make the use of formula, you're going to have du to be equal to this one times this 1 dx or just dx. Then the other one, after you have selected the u out, you have gotten the du. Let's go v now. Let's get v. What's the v? The v will become the other function. If you remove this one, what will be left here? Exponential x dx. Exponential x dx. That will be our dv. Now to get v, you integrate this side, you also integrate this side. This will cancel this, only v will be left there. So v will be equal to integrate exponential s, it will remain as exponential x, it will not change. It will not change, it will remain as exponential x. So next thing, go to this formula and input everything here. So we're going to have uv minus integral v du. So what is u? Our u was x, we have x. What is v? V was exponential x minus integral. What is v? Exponential x. What is du? Du is 1 dx. The next thing we're going to have s exponential x minus exponential integral exponential 1 times dx will be of ds. So after everything now, we have substituted our something like terms, and we are having this now. So next thing, let's integrate what we have. Integrate exponential s ds. What do you have? We have s exponential x minus integrate exponential s ds. This will be exponential x. Then you have to integrate again. Integrate exponential x factor to s will be exponential s. There's no that again. We plus c now. That will be the answer. Or you can say exponential s is common. Bring out to exponential x. We have s minus. This one exponential s is s going out. We have 1 there. Plus c. That's what I'm going to have. So this is how we do division by part. First is select your u. Then, okay, let's try this other one. So that this one I use one to explain that's how you get it. Integral s squared exponential x dx. So the first thing you do, you select out your u where. U for this one, what is u? It is s before exponential x. So s will become the u. S squared is the u. Then the u will now be differentiate this one. We will have 2x, then dx. That will be the u. The next, to get v now, we will now integrate the remaining one. That's how to get v. You integrate the one left. So if you integrate exponential x dx, without the one exponential dx one left, that will be exponential x as well. So you go back to this place, you put the values there. So we will have uv minus integral v du. So that will be uv, which is u is s squared, v is exponential x minus integral v is exponential x times du is 2x dx. That's what I do have. So this will give us s squared exponential x minus integral. Let's move out 2 now. Let's move out 2. Bring out the 2. We have x. Or you may decide to just leave the 2 like that. If you move it out or you don't move it out, you get the same answer. I just have 2x exponential x dx. That's what I have. So we have to integrate 2x exponential x dx. We have s and x. You see how to put there. You have to put this there. So if you decide to also move these 2 outside, you have x exponential x, which was what we did before, x exponential x, and we used integration by part to do it. So as far as these 2 terms that are here, that are having s, 2 functions of s that are there, you must integrate them using integration by part. So this person, you are going to for this second one now, you select your u and your v. So let me put this 2 here. So our u there now will be this same function of s, which is 2x. Then the u will be differentiate 2x, we will have 2. Then v will now be integration of the other one, which is exponential x ds. That will be exponential x as well. That's how we do it. You must select your u using this order, then differentiate the u. Then v will now be when you integrate the remaining one. So this will give us, okay. Now what we are going to substitute, for this one, for this full question, what we are going to have here. To solve this one, what we are going to do. It will be s squared exponential x, there's something here, minus, this one you still use this formula uv minus integral v du. Because this formula we use, we want to solve 2 terms that have function of s, what to integrate them. So when you just substitute what we have into this piece, we're going to have s squared exponential x minus bracket u for this is 2x, v is exponential x minus integral v is exponential x, and then du is now 2 dx. So that's what we're going to have. Then this one gives us s squared exponential x minus 2s exponential x minus, look at this 2 bracket exponential x dx. So the next thing now we're going to do, the next thing we're going to do here now will be we have s squared exponential x minus we have 2x exponential x, then 2 integrate exponential x, we have exponential x, then plus c. If you integrate exponential x, we have exponential x. Then see there's no other thing, integrate again, 2 plus c. This is how I don't integrate this one like this because there's no other thing there. We do have only one thing there. If I integrate only exponential x, then the answer will remain as exponential x. So that's how it is done. So we put the bracket, we're going to have s squared exponential x minus times this, we're going to have minus 2x exponential x minus this one times this, minus times we're going to have plus 2 exponential x plus c. So that will be the answer to the question. Or you can say, we have exponential x everywhere. You can bring out that exponential x, bring out exponential x, that will be s squared minus 2x plus 2 plus c. So we're going to have as your answer. So we're going to have as your what? As your answer. Now, see how two questions here to solve. So take note of the two questions, we're still going to solve them. Take note of them. It's very important. Extremely important. So we're still going to solve these questions. We're still going to solve those questions. So just follow what we are doing here, and you are already good to go. You are already good to what? To go. So let's start. The next one is integral x log x to base e dx. For this one now, from that rule I gave you, the first one is log x, and log x is here. So our u here now will be log x to base e. Then the u will be differentiate log x to base e 1 over x. And put the s at the back after everything. Then v will now be when you integrate the remaining one. If I remove log x to base e, what will be left here will be x and the x. I will left out. Then if you integrate s, you're going to have s 1 plus 1 all over 1 plus 1. Remember to integrate s a polynomial function. Because s is power 1. You add on to this one and divide everything by that same power, which is add 1 to 1, divide it by that same thing. You're going to have s squared over 2. Remember that's how we do integrate polynomial functions. So we're going to have this. Now, going to the formula, our answer will be uv minus integral v dg. That's what I'm going to have as our answer. So this will give us, uv minus integral v du. uv minus what? Integral v du. Integral what? Integral v du. So the next thing now will be, let's go. Let's substitute. Use what? Log x to base e. V is x squared over 2 minus integral v is what? S squared over 2. Then du is 1 over s dx. 1 over s what? Yes. So the next thing we're going to have will be, having here will be s cancel 1 of this x. So 1 over 2 will go outside. Look at it. 1 over 2 will go out. So we have it. This one now. Log x to base e times s squared over 2. This s squared over 2 will go up, but this log cannot multiply this, but they are not the same thing. So we're going to have s squared over 2 log x to base e minus integral 1 over 2 we move outside. So we're going to have 1 over 2 integral x then dx. 1 over 2 is going to have only s then dx. So if you integrate s ds, remember if you integrate s ds, remember it's s over 1. We don't manipulate if it's 1. So we're going to have s squared over 2 log x to base e minus 1 over 2. Integrate this now, we're going to have s squared over 2 plus c. So if you check, we have s squared over 2 here, we have s squared over 2 here. You can move it out, we have s squared over 2 here and here in brackets. What we left here? Log x to base e. And what we left here? 1 over 2 plus c. This is what we have here. Then the third one was integral. What is it called? Integral s cos x dx. S cos x dx. So remember our u is what? X. The u will be 1 dx. Differentiate this one, I'm going to have 1 dx. The v will be integration of the other side is cos s dx. If you integrate cos s, what I'm going to have? Integrate cos s, what I'm going to have? If you integrate cos s, you're going to have sin x. That's what I'm going to have. If you integrate cos s, you have sin x. So you have something very nice there, a very lovely something. So this will give us the answer will be uv minus integral v du. uv minus integral v du. What is u? x. What's v? Sin x minus integral v sin x. Then use what? 1 dx. So from here now we have x sin x minus integral sin x dx. So that gives us x sin x minus integrate sin s ds. What are we going to have? If you integrate sin s ds, what will we be having there? If I integrate sin s ds, I'll be having minus cos x plus c. If you integrate sin s, respect to this, you have minus cos s plus c. We have done that. So we will have lastly s sin x minus times minus to give us plus cos x plus c. Answer. That is what we are going to have. So let's look at shortcuts. Alright, remember the question was integral s cos x dx. Remember, we already have the topic under this division by part 2. You can go back and look at the topic again after this one. So if you want to do shortcut, do like shortcut. First of all, identify your u first. Then to get the v, as you get v, I already told you how to do. Integrate the other side. Which one between s and cos s? Which one will be the u? Cos and sine can never be u self. You don't take cheap functions as u. You only take either exponential function, logarithmic function, or polynomial. If logarithmic function is the first one, if there's no log there, you take s. If there's no s, you take exponential function. So this one now, we have s over something here. So you just take this one as u. So you write out that u. Then you now integrate the other one. Integrate this one. Integrate cos x. I'm going to have sin x. Then you are done with that question. Then from that formula, the next thing is minus. Then you come. Then you start integrating the v and you will be differentiating the u. Remember the u was the x, then this other one was the v. V is going to integrate the other part. That will give you v. Now, differentiate this one, you have 1 times integrate sin x, you have minus cos x. Then, if you differentiate this one, it will be 0, then you stop. Now that your u have been reduced to a constant, say that if you differentiate it becomes 0, you stop. Then, r plus c. Automatically, the answer will be x sin x minus times minus plus 1 times cos s plus c. Answer. It's as simple as that. Very, very simple as that. Look at it. Let's see we have something like this. Let's see we have another one. S3. Let me use cos as well. Cos x dx. What you do? First of all, choose u. U is s cubed. Write down that. Then the other one, we integrate it to get v. Integration, I'm going to have sin x. Then you are done with this. You come back to this. Then you start differentiating your u and you'll be integrating your v. Differentiate this one, minus, the first one will be minus. Differentiate this one, you have 3s squared. Then integrate this one, you have minus cos x, close it. Differentiate this one now. Now, if you use minus for this first one, the next term you are going to write, you use plus. The signs between terms will be alternating. If you use minus for this first one, the next term will be plus, next one will be minus, next one will be plus, and so on. It will be alternating. The signs will be alternating. Also take note of that. Then you use plus now. Differentiate this one, we're going to have 6x. Integrate this one, I'm going to have minus sin x. You close it. Then minus again. I use plus and use minus. Differentiate this one, you have 6. Integrate this one, you have minus plus s. Minus will be plus. So this will be minus. Integrate this one, you have minus cos x. Then differentiate this one will be 0 plus c. Since you differentiate 6 will be 0. Then you just start to finish everything. I have s cubed sin x minus times minus plus 3s squared cos x. Then this one minus times plus minus 6x sin x. Then plus minus times minus plus minus 6 cos x plus c. That becomes the answer. So lastly, we can do this integral x exponential x. Let me use s squared. Which one is v here? Where's the V here? The V is what? Guys, there's no V, dx. There's no V. V is when you have choosing your u, then you now integrate the other one to get V. Guys, u between this. U is what? S squared. It's not, the first one is not u. The procedure I gave you, that is the procedure to picking u. Log first. If there's no log, then you take s plus something, or you take exponential x. Then to get V now, you integrate exponential x, take exponential x. Then minus, then you start differentiate 2x, you have 2x. Integrate on you have exponential x as well. Then plus, take minus, take plus now. Differentiate 2x, you have 2. Integrate on you have exponential x. Then minus, differentiate this one, 0. There's no need of doing it again. If you differentiate the u and become 0, you stop. You add plus c. So give us exponential will come out. Since they are common, we have s squared left, 2s left, and 2 left. This is how we run this. Thank you.
Alright, take note of this. The shortcut won't work for any integration by parts that has log x to base e, or the combination of both exponential function and trig function. For now, the shortcut won't work very well for things like this. Anything like exponential function and trig, it will not work, like these two questions now. Then anything that has this log x to base e, it will not still work. So please take note of that. Take note of that. It's very, very important.
Alright, now let's look at the case of integration of this type. We have exponential x and trig function. How do you do it? Exponential x and trig function. This one is a very special type. We combine exponential x and trig function together. Now remember the use here is what? Exponential x. Shortcut cannot run this for now. Then the u will be exponential s dx. So we differentiate exponential x, it will be the same thing. V will be integrating the other side. Integral sine x dx. That will be minus cos x. Supposed to add plus c, but don't do it because you are still working. Then from this formula, uv minus integral v du, you have something like this. U is what? Exponential s. V is what? Minus cos x minus integral minus cos x. Ds is what? Exponential s ds s du. Du is exponential s dx. So the next calculate now, let's write everything. We have minus exponential s cos x minus exponential s cos x. Then but you bring this minus out. Minus equals plus integral exponential x cos x dx. You see? If you have another thing there to integrate it. You have something like, look at this. I'm still going to use this one there. We use integration by parts. You see how exponential x cos x. Because we have exponential x and x here. Let's go. This one will still be this. We still take this shape. We still take this shape. We have something like this here. How will still be minus exponential x cos s plus this one will still be uv minus integral v du. This is the formula for integrating anything that have two things like this, which is a product function. So, and they are similar. So, to do that now, we are going to s cos x plus, now which one is u here? U is exponential x. Then v will be one integrate this one. Integrate sin cos x. What do you have? You have sin x minus integral sin x exponential x. Du is going to differentiate that your u. Differentiate this one, we have exponential s dx. Exponential s dx. That's what we have. See, it is still going over, still going. Exponential x cos x plus exponential x sin x. Exponential sin x. Exponential sin x. Then minus integral exponential x sin x dx. That's what we have. But there's a problem here. And what is the problem? The problem is the thing will keep on being 2. We keep on solving until we'll be tired. So what do? We discover that if you have exponential x and trig function, after you have integrated 2 times, you have done the first one the second one. You discover that this last term will be equal to the question. Check this question. Check this one. This is the question we are solving. Check what you have here. If they are not the same, check. Are they not the same thing? Check. This integral exponential s sine s ds. Integral exponential s sine s ds. So since they are not the same, it's okay. Therefore, let the question integral exponential s sine s ds be equal to I. So let the question be equal to I, so that the question itself, which is I, will now be minus exponential s cos x plus exponential x sine s minus, this one is still the question. So let that be I, but that's still the question. So that I will now be exponential s cos s plus, open everything, remain the same, exponential s sine x minus I. I will come to this side. We have I plus I is equals to minus exponential s cos x plus exponential s sine x. The next thing, I plus I is 2i. So we have 2i. We have 2i. Like we're going to solve it algebra as we are doing like what we do in algebra, simple equation. Just find the unknown. The unknown is I. That's what I'm trying to do now. Just find unknown out. You have minus exponential x cos x plus exponential x sine x. Next, divided by 2. So by 2 can cancel this. Then the I will now becomes. Remember, we can even interchange this. So we can write something because this minus. We can say plus this minus this. We can do it like that now. Or move back exponential. Move back the exponential this thing, exponential x. Then we can just write this one before this. We say sine x minus cos x. You can do it like that. You can also say minus cos s plus sine s. You are still correct. Still correct. You can also say exponential x over 2 minus cos s plus sine s. You are still good to go. So this is how we do this for 3 portions. Over integrate the first time, integrate it again, then you now call your question I. But this one, the question will be showing here after you have integrated the second time. Then find that value of I. That will become the answer. That's how we do this. Remember the shortcut we did? The shortcut is for x and exponential, s and 3. That's what we use the shortcut for. S and exponential, s and 3. X and log do not work. Exponential and trig should also work. So remember, we found the shape of something now. Before right after you integrate the other one to get your v. Next, you take minus, take your minus, and write this now. Differentiate this one, you have minus 1. Integrate this one, you have sine x. So I'm going to have. So the next thing, differentiate one, you have plus c. That will give us minus x, cos x, plus sine x plus c. That becomes the answer. Just stop there. That becomes the answer. The final answer. So please take note of this shortcut. After you pick out the integrate the other one to get this, then you start differentiating this and you integrate this. Differentiate minus s, you have minus 1. Integrate this one, you have sine x. The next thing, division will be 0, you have plus c. Just to verify everything, you get your final answer. So thank you all. God bless you. I'll see you guys in our next class. Thank you. God bless you.